So I'm Sherlock. I'm co-founder and CEO of Mass Network. We are building a bandwidth marketplace, and we use the protocol to aggregate resources all around the world for their bandwidth. Most of them based in data center, and then we can use these resources to serve like decentralized storages, like NFT platforms and stream medias. Yeah, so that's us. And today I want to share three stories with you. Yeah, simple and easy. I guess cost 15 minutes, and I will share you like some slides about our corporations and how like we have some adoptions from the market. So first story, the story is about what I learned from proof of work and how we apply it on bandwidth. This year is crazy. Like I just back from DevCon Bogota, and Ethereum has like fully changed to the ETH2, the proof of stake version. And some people will like bargaining and we're debating about proof of work, proof of stake. But what's my view about when building the crypto mining pool, a proof of work pool? What I learned for the proof of work. So it's about electricity. The electricity have two features. The first feature is electricity is very hard to store, right? So if you generated the electricity made from wind from the sun, you need to have the battery to store things. So that's why so many like tech giants and scientists they are developing the battery technologies to solve this problem. So this is what first features. The second, electricity is expensive to transfer. Like right now, the audience you are in Lisbon, so you better use the electricity from maybe from Europe, from West Europe, and you can use right now like Australia generate electricity to serve you. So this is electricity hard to store and hard to transfer. And then what's value that being bought by the proof of work? Okay, right now, even though so many countries, so many like cities, they have lack of they need the electricity so much. But if you look at the all around world, the total supply of the electricity is more than the demand. So, but in some specific area, they are like lack of the enough suppliers. So proof of work give you like one choice that people or anyone during any place on the earth, they can use this technology to convert the electricity into currency. Maybe if Bitcoin, it's called BTC, right? So Bitcoin is very easy. Currency is easy to store and easy to transfer. So that's the value I learned that the proof of work took. And then when I built in the mass network, we found the bandwidth had the same features. First, bandwidth is very hard to store. Like right now, I'm not sure whether based, if you're not based in the Lisbon, the city, right? Your home bandwidth right now is underutilized. So you have no idea how to use your home bandwidth, even though you have paid for telecom. First, hard to like store. The second, bandwidth, it has the local, they have the local demand, right? Right now you're Lisbon, same thing happening. You can use the bandwidth from like from the US, from Australia, from Singapore, from other countries to serve the people right now. You are based in the West Europe. You should use the telecoms around you, maybe 10, 20, 50 miles away from you. And then they have like maybe the satellite or maybe they have the base station so they can transfer data to your mobile devices. And for somehow we found bandwidth had the same pattern from the electricity. So maybe we can learn from the ideal design proof of work. So we can design some mechanism which convert the resources bandwidth into a new currency. Right now we call them Mason, right? So this is the first story. We learn how like crypto, how blockchain solve problem, and we practice in our space. The second story is about uh, the adoption of crypto infras. We are kind of like offering a crypto infra. You can regard as the retrieval market, like the big summit we talked today, and we are building a Web3 crypto CDN service to the world. So people still like worry about, okay, compare with the Web2 solutions, right? Like AWS, S3, Cloudflare, Akamai, yeah, like Google Cloud, so many good solutions. What's your like advantages, right? Can you have like much cheaper price? Like could you offer better performance? Are you more reliable? Right. So people will keep challenging you. So then some projects and they will ask, okay, what's the reason for me to use the crypto inference? And on the other side, if you are building a crypto inference, like what's people you should target? My answer is there are two kinds of cases right now I have observed which should use a crypto inference, right? So if you are building a product, you're building your project, your main goal is try to engage more users into your system. You need to like satisfy users. So if you choose the crypto infra, which has maybe worse performance than the AWS S3, and you lose your users. So I mean, it's meaningless for you to use the things, right? You should target users at first, and then I observe one kind of use case they have to use a crypto inference. Let me give you an example. So that's the first case. I know one game company, and they want used to deploy their like the data transfers on AWS, and then during maybe around 3 weeks, there are so many like people need to upgrade their version of their game, right? So it's like a game package distribution problems, and they pay the money to the AWS. They even pay higher than the rest of users. And AWS has and the business is totally legal in the country, right? And then AWS said, looks like you have cost me so many resources, even though you paid me, even though you are totally legal. But the point is, if you are a business which can like maintain for 6 months or 1 year or maybe longer, it's good because AWS can like buy more machines to serve you to earn money from you. But maybe you are just 3 weeks or 4 weeks business in the demand, right? So I can assure you that next month or 2 months later, you are still using AWS. So during that case, this kind of gaming company, they have used so many AWS resources and which has affects the rest of AWS users. So during that part, AWS said, okay, you need to leave AWS. You can't use our cloud service. Even though you are totally legal, you have a bit old agreements, but AWS will kick you out for no reason, right? So during that part, projects like them, they need to seek some solutions which will not restrict them for weird reasons, right? They pay the money, they obey the rules, they can use the service. So that's the first case. They will choose the crypto inference. The second case, yeah, also I have experienced people like that. They are an NFT platform, yeah, quite big, and their co-founder told me, "Hey Sherlock, I know that your platform, your crypto infra solutions may not as good as like Fastly or AWS, but I know you gotta be the part of the future infra. So right now I gonna support you. I know, and sometimes I need to pay the extra money to pay some cost, but I want to support you, right? So during that two cases, I found the adoption of crypto infra is gonna be much more easy because we need a real use case. People who can be benefited from the Web2 infra, they need to choose Web3 infra. And the second, some like pioneers, they want to support you and to make the things accelerate more fastly. So that's my second story. I want to share the adoption of crypto infra, and also for people who may meet the dilemma in this space, you can refer this case. And the third is about the scheduling algorithm. Yeah, third is kind of like a problem I want to share with you. So when try to solve about the retrieval market, a very hard problem is how to schedule your system between the demand and supply. Let me give you an example. if right now you have resources which generated from maybe from OpenSea, and OpenSea generated the resources from San Francisco City, and then you need to like get these resources from Lisbon because people joined the summit in Lisbon, and so many people, maybe thousands or 10,000 people there. They say, okay, I want to consume data. So the point is, which nodes they should cache the files from San Francisco, how many times he should right now cache, and when people try to like need to get this file, which node should be respond to this request. Sounds like maybe not easy to understand. So let me give another example. When I try to understand, okay, what's mesh network, the bandwidth marketplace, the value of that, while checking the model, I found it's kind of like Uber. You know, the Uber has very good things, like they solve lots of people's problem. And I read one article from Bill Gurley. He is the benchmark and the early investor of Uber. He said, okay, the best value Uber took to the world is, before the Uber, like people have to follow the same way to work, like 9 or 8 a.m. to the office, finish the work and leave the office at maybe 5 or 6 p.m. Right? Even you call this, sometimes people say we offer flexible. It's just like you can flexible. You can go to office 10 a.m. and leave like 7 p.m. Right? Not quite flexible. And then what's model from Uber took to world? Like Uber give you the right, you can join the work anytime. Right? I once took a Uber and the driver told me right now it's 7 p.m. He took a coffee. He said, it's my morning. I work since 7 p.m. and I leave work around 5 a.m. or 4 a.m. So he said this is his schedule. He liked night. So he chose to work at night. And some people said, okay, right now I need to like pick up my child. So I need to stop work around 3 p.m. And then I can continue to work since maybe 10 p.m. So this is right that Uber took to the world or to the people that you can choose your time to work. And if you need to earn extra money, you can work much harder. You can say, okay, I want to online on Uber for 9, 10, or 11 hours to an extra part. So things gonna happen in the medicine, like when people need to have resources, they have the right to contribute their resources by their own into a marketplace, right? I don't worry about whether we can reach 10,000 or even million or even 10 millions of nodes on our supply side. I think it's not easy. It's not the hardest problem, right? And I also not quite worried about our demand side. Looks like right now crypto infra is hard to get the demand users, but it gonna happen, and one by one and step by step, maybe 1 or 2 or at most 5 years, it gonna be solved. So this is not a hard problem. The really hard problem is how to match each other, like your supply and demand. Like let's look at the Uber case. So for Uber, the part is if you right now have 2 passengers and the passengers has 2 orders, they say, okay, I need to go to different place. They are from different like locations. So also right now we have 2 cars, maybe around this city. And the best strategy, like scheduling problems algorithm, the best strategy is not like match the closest car to closest passenger. It's sometimes like you need to match the first car to the maybe a little far away of the passenger, and let the latter car to match the first passenger. So during that car, the from one like driver or from one passenger, he thought maybe you give me a strategy which is not quite good. But if you look the global city, right, or maybe the global system, they will give you the best organization for the scheduling. So the thing is, if you make the frequency much higher, like in Uber, the order is, I want to go to one place to another place, and a car come here to pick up a passenger and drop off there, right? The same thing is right now, the bandwidth part, I have a file, or maybe I have file chunk, a piece of file. And the file is I need to transfer from one city or from one data center to another data center, or maybe to the terminal, your mobile devices. And which nodes can help me to respond this? And which route should I choose? And if you increase the frequency, like maybe in Uber 10 minutes, you have 10, maybe thousands of orders. But in a bandwidth marketplace, in like digital world in internet, maybe 10 minutes you gotta have 1 million of orders like Uber match each other. So this is first thing, how to schedule the contents very efficiently and very quickly. Right now we use the very easy like brute force way to match them, give them a global table and match with the same location, but I guess we can find a better way. And the second hard thing is during the schedule algorithm, uh, how to distribute, how to design a distributed schedule algorithm. What's the meaning of distributed or decentralized? The meaning is it's you can open source your scheduling algorithm, and anyone else can deploy your algorithm. And you need to assume that insane people, yes, they are selfish. They try to make their own profit the most, right? So you need to give this assumption, and then finally people still follow rules to run your scheduling algorithm, right? So that's the second thing so we need to solve of the core part. Uh, I talk with some of our friends and our teammates and our advisors. Uh, if anyone else you have idea, we'd welcome you to join our GitHub and tell us what's opinion how to solve this problem. We'll try to make it happen. So this is first 3 stories I want to share with you. And the next part, I want to share with like our corporations, like how right now we have achieved from market. Let me share with my screen. So yes, quite easy, right? I have around 20 minutes. So the first part is mass IPFS traffic. We have deployed our gateway, and you can see that it's from last year, November to middle of the December, we have catch some IPFS traffic. Not quite big, around the highest guy, the day is 5 terabytes. Yeah, but still good, still good. We still saw people using the things. And then also we cooperate the Matters, they are a content platform, and they deployed our new gateway, the 3.0 version, on the public gateways, so people can use our service to extract the files of IPFS. Third case is about the Phantom, wallet. So you can see that people can, when people have some like NFT assets, or we call them small files assets, they can use our gateway. So if you deploy, maybe I'm not sure which decentralized storage you choose. So you choose one decentralized storages, and you can use our gateway to accelerate them. And the fourth case is really good. It's about WordPress. So, 2 weeks ago, I had a sharing in Bogota called Sustainable Blockchain Summit. And I shared with them, wow, people talking about we build a crypto infra, we build lots of things. But why we just directly make it easy? We took our solutions into the Web2 product, into Web2 world, right? People are familiar with WordPress. People use WordPress to build their own website, the developers. So we just give them a plugin, right? You can install the plugin, you can use the Web3 infra. Much easier way, right? You don't need to install Brave, MetaMask, browser, anything else. Just try it. This case is about ETH limo. It's really good. We found it when before 1 week before I joined DevCon. So we found like Vitalik has his own website. It's running with like ETH limo and some like IPFS files. So we can give them a gateway. So right now you can saw we configure gateway, and you have a new link here. And when you try to open that, you will found redirection to one of our nodes, and they will show you the Vitalik websites. Pretty cool. Yeah, and this case I want to share with you. It's really good, and it's called messing with the M3 UA video. So I guess people right now, I'm not sure like how many people you have the tech background, but M3 UA is a protocol for the video playing on browser, and most of the time we will use that to play for the live streaming. So you can see here, we right now have IPFS link, their gateway IPFS with file hash. And then if we like decouple it, we'll find that they have lots of TS files. So TS files like much like you have maybe 5 seconds or 10 seconds free. So during that part, we can add the messaging gateway for them. We build a new link, and then we try to play it. So we try to evaluate the performance from the Akamai. Yeah, I like these things. It's Ultraman. And let's see the data here. So bandwidth estimates, you can see the data, and resource download events, and HTML5 statistics, and buffering events, and total frames and job frames. Yeah, so that's a very good case. And that's also the things we right now try to support more well with the IPFS's official gateway, so that people can use the things and they can maybe check. They can have the live streaming, they can check the videos, and they can like have a very good WebRTC protocol compatible. So people just like using the normal Web2 service, the product, and they have no feelings that they're already using the Web3 infra. And yeah, the final case is about the DCCC. It's still in the early stage, but we proposed the data center common credit, and we try to give the measurement of the power use effectiveness, so people can use this way to measure that whether data center has very good cooling system, the effectiveness, and the second utilization rate. And then we make a table so that if we can give a way so that people can be encouraged to choose the supplier which is more sustainable. And then maybe a few years later, the government also said, okay, I can give you some rewards, just like the credit for EV, right? So people can be maybe somehow punished or be encouraged to run in the sustainable data center. So that's the things we try to offer. And yeah, so that's all. Our official website and our Twitter. Welcome to follow and welcome to try the service. That's all. Thank you.
Which vertical are you most excited about? You mentioned loads of use cases, and we've spoken today already about sort of video, metaverse, gaming. Which is the most exciting vertical?
Our way is we build a service which fulfill people's needs, and no matter it's in crypto or not, it's in Web3 or not. So during that part, like, we took the product to the WordPress, to the live streaming, to the platform, the gaming platform and the YouTube platform. So that's the things exciting me most, that we took it to the consumers.
Well, thanks very much for joining, Sherlock. And yeah, hopefully we'll speak to you soon.
Thank you, Patrick.